Percentages are something that can come up quite a bit in our daily lives, whether it's when we purchase something and pay sales tax, or when we get our paychecks, there's certain percentages taken out to pay taxes, as well as probability and statistics. You'll see a lot of percentages in the news when they describe a certain percentage of the population believing something or doing something. So what we're going to do is first start off with just notation and how to get to percentages. We're really going to rely on this calculation here of how to get a percent out is we think about the part divided by the whole. So we're taking something small out of something larger to realize what percentage is that part of the whole. So we have this group's data where they collected eye color. What this is showing with frequency is just another word for count, counting how many. So this is just showing that 13 people have brown eyes in this group, 5 have blue eyes, 2 have green eyes, 3 have other color eyes. So what we have here are the parts. That's what this 13, 5, 2, and 3 are showing. So to get to percentage, what we're going to need to know is what's the whole. So with that, we'll need a total for that group. So if you add up all of those values, then we know we have this total of 23 people. So instead of describing like 13 people have brown eyes, what might be more beneficial is talking about what percentage of the group has brown eyes, especially when you're comparing groups that have different totals there. Like here we have a group of 23 people, but what if I wanted to compare it with a group of 100 people? That 13 couldn't compare to that group of 100 because they're coming from different sample sizes essentially. But what we could do is compare percentages, and we'd expect percentages to kind of behave similarly, but frequency and count's very specific to a certain sample size. So to get to percentage, what we're going to do is start with our calculation. So we'll have that 13 divided by 23. And what we'll want to get out of this is a decimal form of the answer. And when we work with decimal forms of answers, let's go ahead and round to 4 decimal places just to get a lot of accuracy with them. Just pay attention in your homework if it specifies a certain number of decimal places. But if you stick to 4 decimal places, that's very good. So 13 out of 23, if we plug that into a calculator, that would give us a 0.5652. If we take 5 out of 23, that'll be a 0.2174. 2 out of 23 for a 0.087. And 3 out of 23 for a 0.1304. All right, so once we have this decimal form, what we want to do is convert it to percentage form. And moving in this direction of starting with the decimal and changing to percentage, what we can do is take that decimal and move to the right 2 spaces. So what I'm going to do is I can basically just copy down those decimal forms that I got out, that 0.5652, 0.2174, 0.087, 0.1304, and to change it to a percentage, what I'm going to do is pick up that decimal place and move it to the right 2 spots. That's going to show me a new location for my decimal place. Oops, went too far on that last one. 2 spaces, there we go. So what this would look like is 56 and then 0.52%, 21.74%, 8.7%, 13.04%. So this is a quick way that you can change from decimal to percentage. What you could also do that would be equivalent is instead of thinking of moving to the right 2 spaces, if you took that decimal form of the number and multiply by 100 in your calculator, like 0.5652 times 100, then your calculator would show you 56.52, and then it's just your units now would be percentages. So that's how we'll calculate. If you need to go in the reverse of, say you're given a percentage and need to change to a decimal, which is going to come up because typically when we work with formulas and calculations, we'll mostly rely on our decimal form, and the percentage form we'll use in our final solution. kind of our final sentence. We like to speak in percentages, but in terms of calculation, we need to do those calculations in decimal form. So what we can do is just reverse. So like where I was saying move right 2 spaces, now we'd be moving to the left. Or if you're multiplying by 100 in your calculator, you could think of dividing by 100. So what this would look like is if I have this 56.52%, what I would do is pick up that decimal place and move it to the left 2 spots. Or if you took that number 56.52 and divided by 100, then you get out your 0.5652. So I'll need to be converting in both directions with these. Okay, this second formula here comes up every now and then, just in case you want to actually solve for like what is the value of the part if you have the percentage value in the whole. So we'll see that formula come up as well. It's just a rearranged form of this first one, just with a little algebra. So what we're going to do here is go through a few examples, and then I'll even have a few for you to try and check your answers with. So this first one, we're buying a TV. It was originally priced at $799, so that's what we start with there. But it's on sale for 30% off. So this 30% off, that's going to decrease the price. So we just kind of want to keep that in mind of we're decreasing that price by 30%. And then we have sales tax is 9.2%. Now, with questions involving tax, something to keep in mind is tax is always calculated at the very end. Whatever sales or discounts or the strange scenario if they're adding on value or something like that, if tax is involved, do it in the very last step. And also tax is always going to be added on, at least sales taxes. There are taxes that are taken out of things like with a paycheck, but in this case, we're going to be adding on this value at the end. So what we want to do is find basically what are we going to be paying. So first step we're going to do is we're going to take the discount. Now, there are a lot of different ways to do these problems, and maybe you can even get through this with just one big calculation. I'm going to break it down into small pieces, but there are definitely different ways to go about it, and if you get to the same solution, awesome, do it the way that makes most sense to you. This is probably a phrase I'm going to bring up a lot in this class, and it happens in algebra a lot, is whatever tools you already have for solving, and especially with the topics we cover, there can be kind of an intuitive way to solve. Use what tools and intuition you have, but I'm just going to show you the way I think about it, but there are definitely other ways to go about it. So, the discount. What we're doing is we're going to start with that $799, but we're going to take 30% off. So something we could do is look for just how much are we going to decrease by. So at some point we're going to need to think about what is 30% of 799. And that's coming from our second formula up here. I'm using this piece to figure out what's the part, the amount we're going to decrease by, and that's coming from 30% of $799. Now the 30% part, I did my little conversion. This is the case where I'm starting with the percentage. So I could think of that as like 30.00%. But to change it to decimal form, I pick up that decimal and move it to the left 2 spots. So this 0.3 times 799 is the calculation I want to do. We don't want to plug 30 in because that'll throw the units off. So if we calculate this, that'll be a 239.7. And what this shows us is the amount we're decreasing by. So that's basically the sale amount. So to get the price, like the new price of the TV with the sale included, what you can do is take that original price and then we're going to take off that 30% of 799. And this is that scenario where you could have done this in one step, thinking of it as 799 minus, and then plugging in 0.3 times 799 right here. Absolutely correct. So if we do this calculation, we should get to this price of $559.30. So with the sale involved, so this is the sale price. So now that we have that, what we can do is add on the tax. So when they take sales tax, it's going to be on the sale price. They're nice enough to not tax you on the original amount. So what we're going to do is we need to add on this 9.2% of 559.3. Now with percentages like this, 9.2, a common mistake is to change this to 0.92. And I'm going to delete that shortly because that's incorrect. That would be 92%. So you'd be adding on 92% sales tax, which will make a very big difference. They're very different numbers. So the common mistake here is like quickly converting and you'll end up with an incorrect value. So just be very careful in that when we move to the left two spots here, we'll go 1, 2, and because of that open space there, you fill in the blank with a 0. So to be taking 9.2% of this 559.3, it'll be the equivalent of taking 0.092, that's our 9.2% of 559.3, which is going to be 51.46. So that amount right there, that's our tax amount, that percentage of our sales price. So what we need to do is take our sales price plus the tax. So our final price, the price of the TV is, if we add those numbers together, we should get 610.76. So in this week and in a lot of the future weeks too, we're going to be working with word problems. Just make sure that you finish with the sentence answer using units and the context of the question to make sure the answer is clear. So that's dealing with adding on tax as well as a discount. Notice that when we decreased, it came through as subtraction, and when we increased by adding the sales tax, that came through as addition. That's a theme in mathematics in general. If you're making something lower, it's going to bring through subtraction. You're going to be making something higher, it's going to bring through addition. All right, this next piece will also deal with sales tax, but with a little twist to it. So say we found a couch that's at IKEA and it costs $399. And what we're going to debate is, should we go to the IKEA up in Renton, where it's closer, so we'll only have to spend about $10 on gas to get there, but we have sales tax in Washington, versus should we go to the IKEA location in Portland, where we'll have to pay more gas because it's further away, but there's no sales tax there. So what we're going to do is compare costs. So let's figure out our costs for Washington. So we're going to have sales tax, and again, this is that kind of tricky scenario, 6.5%, but we're moving to the left by 2, so we'll go 1, 2, so this will be a 0.065. So to figure out our tax, we'll take that 6.5% of, so we're going to multiply with 399, which is 25.94. So if we think about the cost of the couch, if we go to Renton, then what we'll have is $399 plus that $25.94 for tax. And then we also have our gas money of $10. So in total, if we buy this in Washington, we'll spend $434.94. So let's compare that to Oregon. Oregon, there's no sales tax, so we don't need to do any sort of calculation with a percentage here. All we're going to have in Oregon is the price of the couch plus the gas money, which will be $429. So in comparison, the better deal is that $429. It'll be less expensive. So what we can say here for a conclusion is Oregon would be a better deal. So it'd be worth it to travel that far. What we could even do is figure out how much of a better deal it is by looking at the difference between the two. So if you take that $430 0.94 and subtract 429 and look at the difference between them, I think it should be a 5.94. Then what you could say is Oregon would be a better deal by about $5.94. So there's a little cost comparison, but let's see what happens when we change the cost of the couch. Let's say it was a cheaper couch at $199. Let's see if the situation changes. So with Washington, taking that 6.5% sales tax of the $199, so now we have sales tax of 12.94. So we're going to have the cost of the couch plus the sales tax plus the $10 gas money. So for Washington, it would be $221.94 to buy the couch there. If we go to Oregon this time, $199 plus the $30 gas, $229. And now it's switched around in that with a cheaper couch, it's better to go to Washington, pay less gas money, and the tax isn't enough to make up for the amount of gas you have to pay to go to Portland. So in this case, Washington would be a better deal. And if you look at the subtraction of the two, it would be by about $7.06. All right. Something we could do is talk about percent increase, decrease, or you could think of like percent change or relative change. And what we want to do is see what's the amount that has changed, how has it increased, how has it decreased out of the original amount that we started with. When we use this formula, even though we're working with increase, decrease, that numerator, make that always positive. There are ways to work with this with negatives, but sometimes it leads to more errors than it being helpful. So what you can keep in mind is in the wording, they'll be cluing you in as to whether you're increasing or decreasing. Just keeping that in mind, just keep the values positive to work with. All right, so this first example, we have the value of a car dropped from $7,400 to $6,800 over the last year. What percent decrease is this? So what we have is this starting amount and then how it changed. So this 7,400, that's going to be the original amount that we started with, and then the 6,800 is the changed amount. So what we need to do is see what's the amount that it's changed. So we're just going to look at the difference between the two, and this is where you could just always keep it positive, always take the larger number minus the smaller number for ease. And when we do this, that should be a difference of 600. So if I want to find this percent decrease, in the numerator, we'd see the amount that it decreased by. So we had the $600 decrease out of, and then the original amount of $7,400. And taking from the calculator, we'll get a decimal out. And then when we make our sentence, we'll make a sentence with the percentage form, because it's just what we speak in more often. So the percent decrease is 8.11%. Let's look at another example with this. So we have a cafeteria used to sell warm chocolate chip cookies for $1 each. They recently raised the price, so we're seeing an increase here to $1.75. So they're telling us this original amount, this is where we started, was at $1, and now it's increased up. So by what amount did the price increase? So for the amount, what we'll do is take the difference of the two, which will be 0.75. So the price increased by 75 cents. And if we wanted to know the percent increase to get an idea of like what portion is that of the original amount, so then we could talk about percent increase and taking that amount increased over the original amount, which was 1. So this is going to be a little strange, but it's because we're dealing with that original amount of 1. It also gets 0.75 out. But when we make this a sentence, this is a percentage. So the percent increase is 75%. So this is kind of a nice comparison here. Like if I was describing at even without the context of it being cookies, if I just said, hey, there was something and it increased by 75 cents, maybe your response would be like, oh, 75 cents, that's not much, nothing to worry over. When you put in context of a percentage though, if you say, well, this price increased by 75%, a lot of people would be shocked by that. That's a huge price increase, and since we're dealing with at a small scale of $1 and $1.75, I mean, if I turn this into $100, that means it would now cost $175. It would be a big chunk of change as the scale changes. So that's where understanding the percentage can be really helpful, because in terms of just 75 cents, maybe it doesn't seem like a lot, but on the scale of a percentage of the original amount, that was a huge price increase that they're doing there. All right. What I'm going to do is with some of the videos that we have, I'll have a kind of you try section. It would be like the equivalent of if we were in class, I would give you problems to work on in class and we would check the answers together. So what you could do is go ahead and pause the video and try these problems for yourself first. And then what you could do is check the solutions with the video, or you can even look at the completed notes and just compare and contrast. But it's a good chance to try out these concepts and then see if you have any questions coming up. So if I start the solutions here, this first one we have Lanisha has calculated that it costs her $4.82 to make 2 spring rolls. If she has a markup of 75%, kind of just like they did in that cafeteria scenario, and she's doing that markup on all items on the menu, what should she charge for the 2 spring rolls? So basically what we want to do is increase that $4.82, that original amount, by 75%. So what we could do, and again, so many different ways to go about this, so if the work doesn't look exactly the same, totally fine, but we should end up at the same answers. But basically we're going to need to know what is 75% of the $4.82. So that'll be my first step here. I'll take 75 cents of $4.82, and that's going to be a 3.615. So that's going to be the amount that we increase by. So what we're going to do is take the original amount, that $4.82, and we're going to add on the $3.615 and get a final answer of 8.435. If I make a sentence here, the 2 spring rolls will cost, or let's say the price of the 2 spring rolls will be, and then we're dealing with money here. So something that I say in my classes is that, like, in the math part of our work, we want to keep the numbers as exact as possible. Keep all the decimal places as long as you can. Store values in your calculator. But then show me that answer. Like, I do want to see this 8.435 because that's the mathematically correct value. But when you get to the sentence, it's like you're presenting this information to someone else. So we kind of want to think about how we would speak to another person. And what we can do here is when you get to the sentence, round to what feels comfortable for you. Like with money, I'm probably going to round to 2 decimal places so that it does represent dollars and cents. If we were solving for like number of people for this question, I'd probably want to round that to a whole number and not have decimal places at all. So in your work, just keep it as accurate as possible in the middle of the work, and then for your final sentence answer, round how you feel is right. So I'm going to change that to an 8.44. So $8.44. All right. Then this last one here, Tammy buys a purse in Iowa and is charged $5.94 in sales tax. The retail price is $99. What percentage of sales tax is she charged? So this could go back to our original formula. That's the idea of if we want to know the percent that's changed by, what we could do is in the numerator put what was the part out of the whole. So before tax, it was $99, so that's going to be the whole. And then the tax part is the part that we added on, so that's going to be the 5.94. So to see this percentage, we basically want to know what percent is that $5.94 out of that $99, so that's where we end up with this fraction. And that should be a 0.06. So there was 6% sales tax when she purchased the purse. All right, that's how we'll be working with percentages.